Hey guys, so today we're going to talk about the Michaelis-Menten equation and enzyme kinetics. So in this class, this is not a math class or anything, so you don't need to memorize this equation or understand how to derive it. You just have to understand what it's telling you, and you begin that with understanding the different variables involved. So here, V naught is just the initial velocity. V max is the maximum velocity that the enzyme can convert substrate into product. You have S in brackets, which just means the substrate concentration. And then we have Km, which is the substrate concentration at half Vmax. So here in this graph, you can see it starts out linear and then kind of tapers off and becomes a plateau. And during this linear part, this is when you have a low amount of substrate. So as you add more substrate, the velocity increases because there's more substrate for the enzyme to convert to product. But as you add more and more substrate, it gets to a point where the enzyme becomes what is known as saturated, where it's converting the substrate into products as fast as it can. And even if you add more substrate, it can't convert it any faster. So when the enzyme is converting substrate to product at its maximum value, we call that Vmax, which is technically a fictional value because the enzyme can never actually reach Vmax. It can only get infinitely close. So we measure enzyme kinetics at half Vmax, and the substrate concentration at half Vmax is known as Km, which is also known as the Michaelis constant, and it can be used to see a substrate's affinity for the enzyme. But because enzyme kinetics is complex, it's not the best way to measure this. You also have Kcat, which is known as the turnover number, and that's the number of substrate molecules that the enzyme can convert to product per second. So if you take Kcat and you take Km, you can put that into one value known as the specificity constant, which is Kcat over Km, and that is used to measure enzyme efficiency. So to get a good enzyme efficiency, to get a good specificity constant for a good enzyme, you want a high Kcat and a low Km. A high Kcat refers to an enzyme converting substrate to product at a high rate, and a low Km value correlates to high affinity of the substrate for the enzyme. So basically, if you have a high Kcat and a low Km, then you have a very large specificity constant, and the higher the specificity constant, the more efficient the enzyme. So I hope that helps.